All right, so I think I'm recording. Let's take a look at problem 7, 8, 9, and 10. Now, this was the reason I turned this into a study guide. Um, Remember today that I had changed the graph. I came in on Word and cut and pasted the graph and put a new graph in there, but I forgot to change the table that went with this graph. So the table was related to an old graph, and that caused confusion, and I didn't mean to cause confusion on the test. So that's why I thought it was just fair to say, hey, we'll turn this into a study guide and test later. So let's double check and see that these points are on the graph. Negative 8 comma 4, negative 8 comma 4 is right there. Negative 6 comma 0 is right here. Negative 4 comma negative 4 is right there. And 0 comma negative 4 is right there. And 4 0 is right there, and 6 2 is right there, and 8 0 is right there. So this time, this is the table that I projected up on the board, and then I had you guys copy down. Now, in copying it down, I was afraid too that somebody could accidentally switch numbers or skip a row in this table. That's why, again, I think it's fair to just call it a study guide and give you a similar test and use this to prepare for it. Now, when I also, not only did I change the graph, but I changed the equation. So when I was looking at the old points there, I saw that the old y coordinates were divisible by 3. So I thought, hey, I'll put 1/3 out there, because what this is saying, take 1/3 of the output. This is a vertical shrink. And it's a vertical shrink by a factor of 1/3. When you're outside of the parentheses, when you're affecting the output of the function, it behaves in a normal way. So we're going to take all the y coordinates and multiply them by 1/3, or in other words, divide them by 3. Now, I did not intend to give you, y values that were not divisible by 3, because I want you to be able to plot your points and have them be integer values. I don't want you to have to estimate the points. For homework problem, yeah, sure, but for a test, I want you to quickly answer it and move on to the next problem. So this 1/3 is not going to affect my x coordinates. I'm going to have negative 8, negative 6, negative 4, 0, 4, 6, 8. This transformation at 1/3 times the output is a vertical shrink of the graph. It's affecting the y coordinates. We're going to see this graph shrink in from above towards the x-axis and from below towards the x-axis. Okay, now when we come in and we take the y-coordinate divided by 3, 4 divided by 3, well, 3 doesn't divide 4. So I can estimate it as 1.3, and that 3 goes on, but now that's a difficult point to plot on the graph, especially this graph is so small. I've got negative 8, I've got 1. Well, where is 1.3? Is it right here, or is it right here? So yeah, I'm just going to have to eyeball it and estimate it and say it's right there. On a test, I don't want you to take that much time and thought process of just plotting a point. I want it to be an integer value. You put your dot there and move on. Now, this guy creates no problem, because 1/3 of 0 is still 0. But here again, we've got this 1/3 of negative 4. So this guy is a negative 1.3. And here is again, we're dividing it by 3. And that's a negative 1.3. Now, when we divide 1/3 of 0, hey, that's 0. Now, over here, we've got a 2/3. And here we've got 0. So 2/3 is approximately 0.666667, repeating 6. So let's estimate where these points are. And like I say, you'll see that it was a vertical shrink. So negative 6, 0, that's no problem. See, the x-intercept, when you're shrinking towards the x-axis, if you're already on the x-axis, then you don't shrink anywhere. You've reached your ultimate goal there, to be on the x-axis. These guys are coming in, being pushed towards the x-axis. So this point, negative 4, it becomes negative 4 comma, negative 1.3. So I don't know, maybe negative 1.3 is about right there. And then this 0, this point gets pushed up towards the x-axis, and it's negative 1.3 as well. All right. Then we're on the 4, 0. Hey, it stays on the x-axis there. The 6, 2, it gets transformed to 6, comma, 0.7. Because if I round that, well, there I'm eyeballing it. That's as best as I can do. Well, hey, it stays on that same x-intercept. So what happened? What do we observe in our graph? Well, like I say, it shrunk towards the x-axis. We've got this horizontal line. It's now a horizontal line up here, and this point's going like that, and this point is going off like that. Alright, so there's our graph. So like I say, on tests and quizzes, I actually intended for these to be integer values so that you don't have to take that much time and effort to approximate the decimal number. So tomorrow, expect these y coordinates, if it was a similar problem, to be numbers that were divisible by 3. Alright, so I'm going to continue and do the rest of these because they're all the same type of problem. Now here, we see that the transformation is on the x-coordinate. Last time, the 1/3 was outside of the parentheses. It was after we applied the function. If this function was to take the square of it, then it's 1/3 after you've squared it, or if it was a square root. So this 1/3 was affecting the output of whatever f was. Well, f happened to be this piecewise function. Could have been a parabola, could have been absolute value, and it would have still shrunk towards the x-axis. Well, this time, it's inside the parentheses. It's going to be changing the x-coordinate, and those shifts left and right, but it's kind of bizarre in its behavior. Initially, I would have guessed, if I was a student, that if it says x minus 2, that's going to shift the graph to the left, but it doesn't. It actually shifts the graph to the right 2 units. So if I'm going to the right 2 units, I'm affecting the x-coordinates here kind of in a bizarre way, but the y-coordinates are staying the same. That 4, that 0, that negative 4, negative 4, 0, 2, 0. But all of these x-coordinates, instead of subtracting 2 like it says, I'm going to add 2. Negative 8 plus 2. Negative 6. I'm going to plot that point. Add 2. Negative 4. I'm adding 2 to the x-coordinate. Then negative 2. 2. 6. 8. 10. Now I'll try to make sure tomorrow that these points, if you have your stretches and shrinks or your shifts left and right, that it doesn't, that within the table that it stays in the graph. I'll try to make the graph big enough where you don't have to plot points. See, at 10, 0, we're getting right to the edge of the graph here. So let's plot these points. Negative 6, 4 is, I think, right there. Negative 4, 0, right here. Negative 2, negative 4, right here. Well, see, this negative 8, positive 4 was right here. It got shifted to the right 2 units. See how this went to the right? And see, this negative 6, 0, this x-intercept, it moved to the right 2 units. And you see this point? It moved to the right 2 units. So the whole graph is going to move to the right 2 units. So a lot of students recognize that, and they start saying, hey, as soon as I got my table, I'm just going to come in here and move this point 1, 2 points over. Move, pick another point that's easy to move over, and pick that point and move it over. And then pick this point, 9, 10, call 10 right there. All right, so this guy, this whole ray right here, got moved to the right 2 units. This horizontal portion of the graph, well, that endpoint got moved to the right. This endpoint got moved to the right 2 units. So it's like that now. And now this line segment that's going up it got moved to the right. And this ray that's going down, it's getting moved. So you can see that my points here were integer values, and that the -2 actually shifted the graph to the right 2 units. So I hope that helps. Let's take a look at problem 9. Now, the negative sign, it's a reflection. So is it a reflection across x or across the y-axis? Are we changing the input, the sign of the input to the function, or the sign of the output? Since the negative sign is on the outside, I'm not changing the input, I'm changing the output. Remember that y is equal to f of x, that this function notation that we're using now, f of x, is just an old school, it's just the y coordinate. So this negative f is telling me take the opposite of the y coordinate. The x coordinates are going to stay the same. The x coordinates are not changing. Now the y coordinates, they change sign. The +4 becomes -4. Now the opposite of 0 is 0. And the -4, it becomes +4. And the opposite of 0 was 0. And the opposite of 2, -2. So when we plot these points, we're going to see that this graph reflects across the x-axis. So this point that was up 4 at that same x is now down 4. This point, instead of going up 4 units, you go down 4 units. Well, you're on the x-axis, so you stay on it. Instead of going down 4 units for this point, you go up 4 units. So this guy that was going up like that is now going down like this. Here you were going down 4 units. Well, now you're going up 4 units. So that horizontal line got reflected across the x-axis. It was down below, now it's up above. And this x-intercept stays the same. You went up 2, well now you're going to go down 2. And this x-intercept stays the same. So this is a reflection across the x-axis. Had the negative sign been in the interior, I would have, this point that was at -8 would have been over here at +8. And that x-intercept at -6 would have been over at +6. It would have reflected it across the y-axis. But with the negative changing the sign of the y-coordinate, it's bizarre in its description that changing the y-coordinate reflects across the x-axis. All right, so let's take a look at this next one. Here I have 2 transformations. One transformation is on the x-coordinate, and the other transformation is on the y-coordinate. Now, with only 2 transformations, the order is not all that significant. When I start having a large number of transformations, when I start getting 3, 4, 5, definitely 6 transformations, I have to be very concerned with the order that I do these transformations. Here, not so much, because it's just affecting one transformation on x and then one transformation on y. So let's start with the x's here. It says to multiply the x-coordinate by 2, but that's not what we're going to do. We're actually going to divide by 2. When you're affecting the domain, when you're affecting the x-coordinates, it's the opposite of what you think it is. It's bizarre in its behavior. So instead of multiplying by 2, I divide by 2. So I'm taking half of all these I'm trying to take half of these x-coordinates. Half of 0 is still 0. So if I haven't made a silly arithmetic error, and I am kind of tired today, I didn't get much sleep last night, so I'm afraid that I am going to make some errors. So hopefully you'll catch it if you're listening to this video. This says to subtract from the output, and that's the normal world. I call this bizarro world inside the parentheses, but on the outside it behaves normally. This is exactly what we expect. I'm going to take all these y coordinates and I'm going to subtract 4. It's going to push that graph down 4 units. See, the 2x is a horizontal shrink. Instead of multiplying by 2, I divided by 2, and the graph is going to, oops, horizontal, see? it's going to shrink in towards the y-axis. This point is going to squeeze in towards there. This point over here is going to squeeze in towards there. And so what are the y's doing? Well, this whole graph, after we've squeezed it in, we're going to shift it down. That minus 4, we're subtracting 4 from all the y coordinates, and we're going to push this graph down 4 units. So subtract 4, subtract 4, subtract 4, subtract 4. I'm looking at the y coordinate, and I'm subtracting 4, and I'm trying not to make any silly arithmetic errors as I'm doing it. So this negative 8, 4 that was right here, it got shrunk horizontally, so it came in towards the distance. Instead of being way out here at negative 8, it got cut in half, and it's coming in to negative 4. But then it also got pushed down 4 units. So it came in, but then it got pushed down. I forgot to write that up here. After the horizontal shrink by a factor of 1/2, because I multiplied all the coordinates by 1/2 or divided by 2. That's the same thing. And then I'm going to go down 4 units. So, like I say, this negative 8, 4 got shrunk in, and then it moved down. So let's plot these points. Negative 4, 0. Negative 3, negative 4. Negative 2. Negative 2, negative 8. 0, negative 8. 2, negative 4. 3, negative 2. 4, negative 4. 4, negative 4. Okay. So this guy got shrunk in and pushed down. This horizontal line, it squeezed in, then got pushed down. So it's not as wide as it used to be, and it's below where it used to be. Then this point got shrunk. Instead of being out at 6, it's out here at 3. And then it got pushed down 4 units. This isn't very horizontal there. All right, so I hope that helps with problem number 10. Let's take a look at problem... Hey, I'll do this on another video. Hope that helps. Talk to you later in a minute.